G'day folks, MBS again. Today I want to talk about hydraulic lifters. The good old hydraulic lifter, invented such a long time ago, I even forget. Alright, so here's a schematic of the hydraulic lifter I prepared a decade or so ago. And I've used this a lot in lesson planning that I used to do when I was younger, teaching young mechanics. So I kept it all these years locked away in a cupboard, and here we are again using it. Alright, now I'm going to show you a schematic, not a schematic but an actual lifter pulled apart, so you know all the bits and pieces that are in there. And as you can see, it's pretty simple, not much in there. So yeah, okay, we'll come back to the drawing now and have a look at how it operates. Alright, so as you saw in that dismantled lifter, you can see there was a push rod socket, there was a little oil metering disc. We're working from right to left. Then we had a plunger, then we had a spring and valve body. Okay, that's basically it. Yeah. So what happens, how this actually works is it's meant to take up any clearance, zero clearance, okay, and that's accomplished by oil pressure from under here, that spring tension, and then the locking of that oil pressure in there through the check valve and turns it into a solid lifter. But let's go through how this all operates. Initially, that socket will be pushed all the way down on its stop. In this hydraulic lifter, it's 4mm, a Holden 6-cylinder that I'm talking about. Now you've got Ford, Chrysler, Chevy, Mopar, oh that's Chrysler. They could all be different, alright? And then you've got the hydraulic lifter that's not in an overhead push rod engine like this is. This has got the push rod. You can have hydraulic lifters built into rocker arms like the Mitsubishi. You can have the hydraulic lifter actually built into the tappet sitting directly on top of the valve. So there's all different various types, and they all have a working range. This working range is 4mm, albeit though I wouldn't want to be pushing it to the 4mm range, otherwise you'll get a lifter lock up too early. Alright, so here we go. It's in the motor, you've got oil pressure, you're cranking it over, oil pressure coming in through here. You would have seen the recess cut into the body of the lifter. Oil is allowed to go through that hole, and then it matches another hole in the plunger, and then that fills up the plunger with oil. Some of it will go up through the push rod, and some of it will come down through the check valve and fill up this chamber down below the plunger. Now what happens as soon as the lifter body tries to lift up, that's going to push the push rod down onto the plunger and then create a hydraulic lock. And that's created by this check valve. All the oil that's built up in here gets locked in there. That check valve closes off, just the slightest bit of movement, yeah? So that all gets locked up. That lifter is now a solid lifter, and it opens up your valve then. Alright, so it's pretty easy operation. It goes up, opens your valve, it comes down. While it's doing that, it bleeds off just a little bit, not much in that time. A little bit of oil is lost up through the clearance between the plunger and the body, but that's okay. The lifter will take up any bleed down straight away as soon as it comes back to the base circle of the camshaft. If there's any play in there whatsoever, this spring plus the oil pressure will push the plunger back up against the push rod and take up that clearance. And this all happens very, very quickly, and it happens quietly. You don't hear any rattle in your lifter when there's zero lash created for whatever reason. It's taken up straight away, virtually on the next camshaft rotation. Alright, so that's its basic operation, yeah? Now, the adjustment of the hydraulic lifter. It's always been on a fine thread stud like a Holden 186 179 with a fine thread stud and the fulcrum on the rocker. You could generally turn that nut down from zero clearance, that is when the push rod has got no clearance in that socket, but it hasn't pushed that plunger down. Okay, that's zero clearance in your rocker train. You then tighten the bolt on your rocker arm down half a turn, 3/4 of a turn. You know, that's the industry standard. Most people set it up at there. Some people have been setting them up at 1/8 and a quarter of a turn. which I'll talk about later why I think they're doing that, and there's probably a good reason from their side. But to me, that is too close to the circlip. Okay, you're only going to move. Let's say they've gone down a quarter of a turn. You're only going to move down 0.16 thou or 16 thou, 0.016. All right, so that's not much. That's not allowing for wear and tear in the rocker components. So that's probably not going to last the life of the motor. Okay, but if you do it down half a turn, you know, we're pushing the plunger down about 35 thou, that will last the life of the engine. You won't ever have to adjust the hydraulic lifter again. Alright. Another interesting fact about a hydraulic lifter is that it works anywhere in that range of 0 to 4 mil. That might surprise a lot of people. Alright. So if this plunger, let's say you wanted to shorten the push rod in your Holden 6 because the push rod's too long, the head's been shaved, now the push rod's pushing too deep into there, in effect you've got control of that by adjusting that nut at the top. But what are you going to do? You're going to adjust it at half a turn again, push the plunger down that lousy 34 thou, but the rocker geometry will be now incorrect. You have to turn it down another probably half a turn to push this plunger deeper down to retain your rocker geometry. Now if it's even worse, let's say you've had 40 thou shaved off the cylinder head and you only adjust the rocker down half a turn, you're going to end up with very poor rocker geometry, and you're going to wear out your guides, you're going to wear out your rocker arm, and you're going to wear the tips of your valve stems. Poor geometry. But you can correct that with the hydraulic lifter by turning the rocker nut down further, which will incline your rocker further down like that, push the push rod deeper into your hydraulic lifter, and you can return your rocker geometry by doing that. Alright. Now you can push this plunger down into the body of the lifter. Like I said, 4 mil is cut off. That becomes a solid lifter and your hydraulic lifter won't work anymore. So let's say if you needed to go down 3 mil, alright, you could go down 1 3/4 turns on that nut, on your adjustment, to get the push rod to sit down into the hydraulic lifter about 100 thou. Okay, so yeah, you can use your hydraulic lifter to adjust geometry. Since changing push rods is quite expensive, you can do it automatically just by adjusting the hydraulic lifter. In other words, yeah, plunger is sitting deeper into a hydraulic lifter. It still works. You will not notice any difference, guys. Nothing at all will change. The engine will run just as good. The caveat to that, of course, is hydraulic lifter pump up. Okay, you've probably heard about that. Now, it's not the lifter's fault. This is not a lifter problem, pump up. It is the problem with your valve train. Now, it could be your geometry's wrong, could be your valve springs have lost tension, or the valve spring is just incorrect for the camshaft. Alright, they have to be matched. When you buy a camshaft, you should buy the whole kit and caboodle. Valve springs, retainers, all that sort of stuff that comes with the camshaft. You'll even get lifters with them most of the time as well. You need to replace as a set so it's all matched. Alright, if it's not matched, you will get lifter pump up because you might get valve bounce, for instance, taking it too close to the red line, and that camshaft's not designed to do that, or the spring isn't designed to carry that sort of RPM. You'll get separation at the valve tip to the rocker arm, which creates a gap. And what's the job of the hydraulic lifter? To take that gap up, yeah? So straight away, this plunger will go higher up into its bore and take out all that lash, and next thing you know, when it comes back to its base circle, the valve is held off its seat because the lifter is pumped up. Alright, that's pretty much how that works. And that's pretty disastrous for some engines. In the Holden 6, not a problem. But close piston to valve clearances, pump up is not a desirable thing. And if you've only got this adjusted, like I said earlier, I think some guys adjust them a quarter, eighth of a turn. They're scared of pump up, I betcha. That's why they do it. So they only want that plunger in a little bit, so if it does get a valve float or valve bounce, the lifter can only pump up 10-15 thou, alright? That's probably the only reason they adjust it to that setting. But they're going to be, that's going to have to be adjusted pretty well once a year or once every couple of years, because it's not going to maintain such a low, shallow clearance due to wear and tear in your rocker train. Alright, so yeah, anything, like I said, anything from round about 30 thou right down to about 3.5 mil absolute max is where you could be adjusting a hydraulic lifter and it'll work fine. Okay folks, look, this is an insert I had to do because my audio just failed on me in this little section, and this was an interesting little thing I don't know if you knew about, but I have to do a retake and do this little section again. Now what I was going to say, another interesting fact about hydraulic lifters is they spin while they're in the bore, okay? Now that's very, very important, and they spin because of that surface, that's, I think that's concave, and the camshaft is ground not straight but slightly offset like so, and when that meets that surface it induces a spin in the lifter as the camshaft turns around. Alright, now that spin is also induced into the pushrod. Okay, so when you're setting your tappets running, you'll see the pushrod turning. Okay, if you don't see the pushrod turning, you've got a problem. Your lifter isn't turning. Alright, so now that could be due to very old age. You've done thousands and thousands of kilometres, so that's normal. Okay, but expect this: if the pushrod doesn't spin, you will wear out the tip of the pushrod and you'll wear out the rocker arm. Okay, it must rotate to get even wear around the entire socket of the rocker arm and the end of the pushrod. Alright, now another reason it might not spin also is the lifter could be tight in the bore. I've seen that lots and lots of times, especially when you're extracting a hydraulic lifter through the top. The bottom of the lifter is bell-mouthed and it's usually got a little ridge on it. When you extract them using a puller, you damage the bore. Alright, when you go to put a new lifter in, they're tight to get in, and if they're not tight, when they move up and down there will be a tight section there and they won't rotate. Simple as that. You can quickly fix that by flex honing the bore and getting rid of any imperfections in the bore that's stopping the lifter from turning. Now I would check the lifter on the base circle of the camshaft, as well as take it up to the nose of the camshaft as well, so up to full lift, and make sure that you can easily spin it with your finger. Alright, so that's just a little point there that I thought important to know, that the hydraulic lifter actually spins and so is the pushrod. Alright, and I'm sure you old timers will have seen the effects of the pushrod not turning. I've seen one just recently in a Holden Ecotec engine, V6. Both sides of the pushrod were flat, okay, almost like a point, instead of having a nice round bulb on the end of the pushrod, and it just chewed out the rocker as well. So consequence of it not spinning. Alright, back to the original video. Right, another type of lifter, exactly the same as this, not much different. The only difference is that the circlip is replaced with a heavy duty circlip, because it's going to be a performance hydraulic lifter, which is usually an anti-pump up. The anti-pump up infers that it'll never pump up, but they do. You can still pump up an anti-pump up lifter, okay, in extreme cases, but they certainly help. And the way they help is by creating extra clearance between the plunger and the body, so the lifter bleeds down. Like you've got quite a few 100 pounds of pressure acting on that pushrod with the aid of the valve spring and the rocker geometry, the 1.5 or 1.6 rocker ratio. It's quite a heavy force pushing down there, right? So that's going to be wanting to push the plunger in, and with more bleed down rate, that plunger is going to go into the body of the lifter a lot easier. Now, anti-pump up lifters lose duration of the camshaft and they lose lift because they bleed down quicker. So you will actually lose a little bit of lift and duration on your camshaft. But cam designers, if you bought everything as a match set and they sell you a set of anti-pump up lifters, their camshaft is designed for that lifter. So they've allowed for that bleed down and changed the specs of the cam to match it. Alright, so that's basically how a lifter works. The adjustment I've covered, your allowable adjustment. And I think that would be about it on that. And of course, look, you've got a roller lifter as well. There could be a roller down here as well, pretty much. So, yeah, so many different designs and bits and pieces to them. And they haven't changed much in all the years. There wouldn't be too many cars now that actually run a lifter like this because of modernisation, overhead camshaft engines. There are still pushrod motors getting out there that are running a hydraulic lifter that is very similar to this. Alright folks, that's about all I think I can cover on the hydraulic lifter. This is going to be, I did this video first, I'm in the process of shooting rocker geometry next, and the part the lifter plays in that is pretty important. You'll soon see. So I thought I'd better do this one first so you've got an appreciation of how a hydraulic lifter works and understand that it has got quite a wide range of adjustability built into it, and you can use it to actually correct rocker geometry errors, and they come about from shaving cylinder heads, decking blocks and machine work like that. Lowers everything down, pushes the pushrod deeper into the lifter, but because you may have an adjustable setup, you'll end up going back to a quarter of a turn and your geometry goes out. So you can use this to adjust your geometry, and that'll become apparent in my next couple of videos. Alright guys, hope you learned something. See you in the next video.